Good afternoon, everyone. Today I am going to present. I am the TA of this course, Reagents in Organic Synthesis, pursuing my PhD from Aizar Berhampur. So in these classes, I usually discuss about some previous year questions based on this topic. So till now, I already have discussed about oxidation reaction, oxidizing reagents, reducing reagents, hydrogenation reagents, and some metal and non-metal containing reagents. So today I will just discuss about some previous year questions based on this type of metal, mainly the transition metals, and also I will try to introduce some new topics. Okay, so let's start. So let's start. The first question is based on nickel containing reagent. In our previous classes, I have already discussed about different type of nickel containing reagents. So this question came in June 2014, CSI and NET. So in this case, let's solve one by one. The major product form A and B. They asked for the major product form A and B. So from this structure you can see this is a nitromethane and base has been added. So if you deprotonate this hydrogen is acidic because of minus I effect of minus I and minus R effect of this NO2 group. This hydrogen is highly acidic. So it can be deprotonated and form this type of so in presence of pH NCO, it forms this alkyne. So this goes here, this open up. O minus. Another proton will be removed and it will comes here, and this gets removed from the system as water molecule and form this type of 1,3 dipolar compound. Now when alkene is added, you know, whenever there is a alkene is given and there is a 1,3 dipolar compound, it will undergoes a 1,3 dipolar cycloaddition. So this will obviously go a 1,3 dipolar cycloaddition. So here this alkene is trans. So you know that this 1,3 dipolar cycloaddition reactions are concerted, so it will maintain the stereochemistry of these two methyl group. So here you can see, and after this cycloaddition reaction, it comes here, this goes here, and okay, so this structure will form. Now the thing is, you have to check here, two methyl is trans to each other, where these two methyl is cis to each other. Here in this alkene, this is trans. Obviously these two methyl should be opposite pair, should be in the opposite place. So correct option will be between A and B. So C and D are already cut. So correct option will be between A and B. So let's go to the next. So the structure of A is this one. Structure of A is this one. Okay. Now in the next step, when this uh, yeah, hydrogenation reaction is performed, there will be a bond cleavage and it will be hydrogenated to form the in presence, and there is, as water molecule is there, so it will be, this ring will be cleaved and it will form this type of imine moiety. The above methyl group and a planar which, and there is a, below the plane there is a methyl group. Now in presence, as water is given, so this imine will be hydrolyzed to form this ketone. Now from the options you can see that OH has been shown in a dash or an OH. So you have to keep this OH in a dash or in a wedge bond. Okay. So because of that, you have to just rotate this bond. To just rotate this bond, this OH comes here and methyl goes to the planar bond. OH comes because this is behind the plane. This H, if you just rotate this one, OH comes here, methyl goes to this planar bond and H goes to this lower bond. So the correct option will be OH will be this, and methyl goes to this planar bond. So correct option is option A. Correct option is option A. Okay. I hope it's clear. So this will be our answer. I'll just give 5 seconds. Just note it down. Okay. Let's go to the next question. So This is also a question based on this nickel containing reagent. In this reaction, what will be the major product X? In this reaction, what will be the major product X? In the first step,
Ladies and gentlemen, please welcome our firm's newest senior partner, the illustrious Anjana Min. Round of applause for her. The only Indian lawyer I consider my equal. बावजूद इसके कि वो मेरी तरह हार्वर्ड लॉ नहीं गई है. Okay, लेकिन आपको बुरा तो लग रहा होगा कि इंडियन यूनिवर्सिटी लॉ से आप आते हैं. India let you win. It's called chivalry. Ain't dead yet.
so there is another question which is based on nickel containing reagent. In this reaction, they have asked for the major product form. So this is a so there, if you just dissociate, there is a one CH3 is there, and there is a CH. Now between this hydrogen and the CH3 hydrogen, which one is more acidic? Obviously the methyl hydrogen. Obviously the methyl hydrogen. So this hydrogen is more acidic. So in presence of base, this hydrogen is more acidic. So in presence of base, this get deprotonated and forms this type of ylide, sulfur ylide. Sulfur, this type of sulfonium ylide. Now, as this is there is a alpha beta unsaturated double bond is there. So this will come here, goes forming this cyclic structure. After that, this O minus returns back, this tucks here, and this opens up, forming this now. In this case, the next step they have used ranitidine. So ranitidine can be used to cleave carbon sulfur bond. So in presence of ranitidine, this carbon sulfur bond get cleaved. So the correct option will be option B. So the correct option is option B. So this is your answer. I just give 2 seconds. Just note it down. Let's move to the next question. So this is based on tin catalyst. We have discussed about this tin catalyst earlier also. So let's solve some question based on that. What will be the major product from A and B? They have asked for the major product from A and B. So from the first step is PPST date. So this is a by the PPST date means I have taught this. This is a Mitsunobu reaction. Date PPST, whenever you see PPST, a combination of PPST and diethyl azidote carboxylate, this reaction means a Mitsunobu reaction. So what happens in, and they have give 2 iodo-phenol. So in case of Mitsunobu reaction, what happens? The OH get substituted. In case of Mitsunobu reaction, the OH gets substituted with a nucleophile. The OH gets substituted with the nucleophile. So obviously this OH is there. I'm not going to into the mechanism, because I have already in my previous classes I have already discussed about Mitsunobu reaction. If you want to know about the mechanism, you can go and check. So here I am just going to the, so just remember Mitsunobu reaction means there will be a SN2 reaction, SN2 substitution of hydroxyl group. It is SN2 substitution of OH group. So as SN2, so as the OH is already above the plane, so the upcoming nucleophile will come from the below the plane. So correct option will be between A and B. So C are already cut. So our A will be this one, where this iodo-phenol attacks from the below the plane. The next step is, in the next step they added due to SNH, which used to so as this group is already below the plane, this group is already below the plane. So to the newly formed bond here, there will be a rotation of this bond, and in presence of Bu to SNH, there will be a generation of radical here. There will be a generation of radical here. This there will be a generation of radical here. Now in this radical we will couple from this side and form a new cyclic structure. Now this ring is all, this bond is already below the plane, so to reduce the strain in the ring, the newly formed bond will also form at the below the plane. So the newly formed bond will form also in the below the plane, keeping methyl above the plane. So this will attack here and form this as our structure. So correct option is option A. So understood, right? Here this is not like attacking. Here there will be a generation of radical. There will be a generation of phenyl radical. There will be a generation of phenyl radical here. Now this alpha beta unsaturated, this double bond will go and coordinate with this radical and form this as a structure. The correct option will be option A. So this is your answer. Just give 2 minutes. I just give 1 minute, just note it down. Let's go to the next question. This is also based on tin containing reagent. What will be the major product A and B in the following reaction? So what will be the major product A and B in the following reaction sequence? So, so there is a so the NBS given, whenever there is NBS is given and there is a double bond, there is a formation of bromonium ion. There is a formation of bromonium ion. Now this OH will attack here, generating a epoxide ring. Another possibility is there is a formation of bromonium ion in this double bond. From the product you have to get an idea, from the options you have to get an idea which double bond will react with NBS. This comes here and this open up. Okay, so from the product you can see the bromine is attached adjacent to the OET. Bromine is adjacent to the OET. So the correct option, the correct will be bromonium ion formation of this double bond. So this is not, so the will next is this alcohol will attack here, and this goes back. I am considering this as R. Okay, so the bromine is a R group and OET. So the correct option is this one. The correct product is this one. So D is already cut, because see, just adjacent to, just next carbon to R there is OET, and after one carbon there is bromine. So the correct will be this one. Okay, now in the next step they have added Bu3SNH. So Bu3SNH will generate a radical here, will generate a radical here. Now as there is a double bond in this ring, it inserted here, forming this as our product. So correct option is option A. Correct option is option A. Okay, so reaction is going through, and whenever you will see U3SNH and any halogen bond is there, carbon halogen bond is there, this will undergoes a homolytic cleavage, forming a radical, and reaction will go through a radical pathway. So this is our correct option. Just check once and note it down. next question is also based on this steam catalyst. What will be the major product X and Y formed in the following reaction? So they have asked for what will be the major product formed in the following reaction. So let's go step by step. So in presence of base, this undergoes the elimination reaction where we take this base proton comes here and Cl get removed from the system, forming this ketene type of moiety. Now we know ketene also acts as a dienophile when there is a diene is provided. So here there is a diene and this it can act as a dienophile. Forming, leading a Diels-Walden reaction. In presence of, now when mu3SNH is added, this carbon Cl bond is substituted with a carbon hydrogen bond. So the correct option is sorry, not this one. I've drawn the wrong structure. If this comes here, so in presence of base, it will form a ketene type of structure which will undergoes a cycloaddition reaction with this diene ring. So this reaction, if 2+2 cycloaddition take place, as we know that ketenes are more prone to 2+2 cycloaddition in presence in a heating condition. Usually 2+2 cycloaddition are favorable in photochemical condition, but if you specifically in case of ketene, due to the the electronic arrangement, the 2+2 cycloaddition is possible even under thermal condition. If you want to know more about this thing, you can go and check Claydon, where this thing is like why ketene undergoes a 2+2 cycloaddition reaction in under thermal condition. So there will be a CH3 and a Cl. Now in presence of U3SNH, this carbon halogen bond will be replaced with the carbon hydrogen bond. So it will be just replaced with a hydrogen. So the correct option is option C. The correct option is option C. So this is your answer. Just note it down. Let's go to the next question. The next topic is based on the reagent containing mercury. Reagents containing mercury. So in organic chemistry, the oxymercuration reaction is an electrophilic addition reaction that transforms an alkene into neutral alcohol. In oxymercuration reaction, the alkene reacts with the mercuric acetate in aqueous solution to yield the addition of acetoxymercury group and hydroxy group across the double bond. And after hydrogenation reaction, this mercury can be replaced with the H. So as this reaction goes through a concerted type of pathway, no carbocation is formed and the reaction follows the Markovnikov rule. So here I have shown the schematic diagram. If you see the mechanism, first this double bond undergoes a cyclic intermediate formation. After that, this OH water will attack and this 3-member ring will open up, and if you add any hydride source into this, then this Hg get replaced with that, forming this hydroxylated product. So based on that, there is various question has been seen in previous year NET and GATE examination. So I have gathered some of them. Let's solve one by one. The major product formed in the following reaction sequence. What will be the major product formed in the following reaction sequence? So as we have seen from the mechanism, so this triple bond will form a mercuric cyclic intermediate with this mercuric acetate. Now instead of water, they have given benzyl amine. Instead of water, they have given benzyl amine. So benzyl amine can attack to this cyclic transition state and it will open up. But the question is, which center the benzyl amine will attack, from this center or this center? So as we have learned that this always follows the Markovnikov rule. According to Markovnikov rule, the center containing more hydrogen will always get the hydrogen. So it will follow the Markovnikov rule. Therefore, this benzyl nitrogen amine will attack here, so that it will open up and this center will be vacant for hydrogenation, and hydrogen will go to that center which is already rich in hydrogen, so it will attack here this benzylamine. After that, this amine will attack to this carbonyl center. Then there will be elimination of water, generating a double bond here, and to gain aromaticity, this proton comes here and this goes here. So the correct option is option D. Correct option is option D. Okay. Understood? Let's go to the next question. This is also based on the same concept. I just give 5 seconds. Just solve by yourself. I just give 5 seconds. The major product of the following reaction is, so let's go step by step. As you know that mercury will be added here and H will be added here. Sorry, OH, as OH is given, so OH will be added here. I am just jumping the step, okay? Till I think you have understood how I have gone through. As it follows the Markovnikov rule, so obviously the OH will go where the number of hydrogen is less. So OH will attack here and mercury will attack here. After that, if you NaBH4 will add it, this bond cleave and we will get this as our product. So the correct option is option C. Oh sorry, not option C. Then now as NaBH4 will not only reduce this carbon mercury bond, it will also reduce our ester group. So in presence of ester, this will attack here and this open up. So the correct option is option D. Correct option is option D. Okay, understood. Only this center will not attack, right? Because all this hydrate source and also our OH minus is provided. So this that will open up this ester and forms the alcohol in the same medium, reaction medium. So correct option is option D. So this is your, sir, just note it down. Let's go to the next question. This is also based on the same topic. Here you can see in the back to back year we have got question from this oxymercuration, demercuration. So double bond is there. So there will be a Hg. So let's go from the scratch. The first, this mercury cyclic transition state will form. The next step, as instead of water they have given methanol, so methanol will attack. Now the question is, methanol will attack here or here? Here there is both the carbon is contain same number of hydrogen, so from the basis the count of hydrogen will not make a difference. So you have to consider the stability of the carbocation. So if you open up this one, there will be generation of carbocation here which gets stabilized by the plus add effect of the adjacent oxygen atom. Because of that, this methanol will attack at this place, forming a OMe bond here, and NaBH4 is added which will replace this mercury bond with the hydrogen bond. So the correct option will be between this C or D. So A and B are already cut. So A and B are already cut. Next is they have given acetone. So this acetone will will bind with this through a kind of ketal formation. Now you always know that ketone always prefers the formation of 5-member ring, whereas 6-member ring. So in this case, these two OH are will attack. The ketone always favors the formation of 6-member ring. So here, if you attack here, there will be formation of 5-member ring. But if these two OH reacts, it will be a formation of 6-member ring. So this reaction this the correct option is option C. It will be simple, just ketal formation, where the as aldehyde protection type of reaction. Okay. So this is your answer. Just note it down. Let's go to our next question. What will be the major product A and B of the following reaction sequence? So on this same concept, this in presence of PPS3, in diazo will get reduced to form this NH2. Now in presence of CbZCl, this NH2 will be protected. So CbZ is benzyl, carboxybenzyl okay. After that, what will happen? They have given this same this Hg acetate, so it will form this Hg cation. So this will attack here and will open up, forming this 5-member ring. Now this is already above the plane, so it will attack from the above the plane. So this both bond will be from the above the plane. And after that, this carbon Hg bond gets cleaved by this NaBH4 and form this as our product. Okay, so the correct option will be option D. So correct option will be option D. This is your answer. So there is some question based on palladium and platinum containing reagent. So what will be the major product formed in the following reaction sequence? Let's go step by step. In presence of H2A2, there will be a formation of epoxide here. This is called a Eastern-Moser type of reaction. Now if you add this tosyl hydrogen, this carbon will get tosylated. Sorry, hydrogen form. Now in presence of base, this proton will be deprotonated, tertiary butoxide. In presence of base, this will be deprotonated, and this comes here, this, and it opens up. After that, this carbonyl goes here, this bond breaks and N2 eliminates from the system. So the correct product is A. So the correct option is option A. I hope it's clear. Sorry, I just missed. Correct option will be, so the carbonyl and between gap is carbonyl 1, 2, 3. As the correct option will be option A. Let's go to the next question. The most appropriate reagent suitable for the conversion of 2-octane into trans 2-octene. So 2-octane, so there is an alkyne. I am not drawing the other part. You have to form a trans 2-octene. You have to form a trans 2-octene. So what will be the correct reagent? So if you add zinc acetic acid, lithium in liquid ammonia, H2PD, or hydrogen hydrate. So obviously this lithium liquid ammonia, because this undergoes a Birch reduction and this is trans-selective. In my previous class I have already discussed about Birch reduction. If anyone wants to know in a broader way, there I have in one of the classes I have already simply discussed about the Birch reduction and where I solved different type of questions based on that. You can go and check from there. Next question is, among the following, the compound that undergoes deprotection easily on treatment with hydrogen in the presence of 10% of palladium carbon to generate RNH2. So, among the following, the compound which undergo deprotection easily on treatment with hydrogen in presence of, so which will undergo deprotection to form RNH2. So the correct here, this will undergo because benzyl can be removed by hydrogen palladium charcoal and it will undergoes a decarboxylation. So the correct option will be option B. The correct option will be option B. The correct option will be option B. What will be the major product in the following reaction? This is a question based on platinum catalyst. So in this reaction, if you add hydrogen and platinum, platinum is a very strong reducing agent. Very strong reducing agent. So in this case, it will reduce this double bond, as well as you know that cyclopropane ring are also act as a double, also considered as a double bond due to close arrangement of p orbitals. So therefore it will also cleave this 3-member ring, forming and in this case there is a ester group, but that will be unreacted in presence of platinum. So these two will react. So the correct option will be option C. Correct option will be option C. So in presence of platinum hydrogen, this ester group will be unreacted. Only the carbon-carbon bond will break and this hydrogenation will be performed. Let's go to the next question. In the following sequence, we have the reaction. What will be the major product Q? What will be the major product Q? So from the reagents you can see NaNH2 is given, and so it will go through a benzene generation. So in presence of NaNH2, this fluorobenzene will leads to the formation of benzene. If we add furan in this, it will undergo a Diels-Alder reaction. It will undergo a Diels-Alder reaction. This goes here. Formation of a new 6-member ring. Now in presence of H2PD, what will happen? In presence of H2PD, there is a hydrogen atom here. So this goes here. This gets removed from this and it opens up. So as a result, we get naphthalene as our product. As is take H plus. So removal of OH. So the correct option will be option C. Correct option will be option C. So thank you everyone. This much for today's class. So today we have discussed different questions based on this different type of metal containing reagent. First we started with nickel containing reagent and solved some questions based on that. Then we went into tin containing reagent. After that we solved some questions based on oxymercuration and demercuration. These questions are very interesting. If you try to solve by yourself, so that it will give you idea how to approach unknown questions, because whenever you are like solving the same type of question, you are seeing it seems easy. Try to solve it by yourself. There is also question based on palladium and platinum containing reagents. So this much for today's class. Thank you everyone. Have a nice day.